Good morning, everyone. My name is Harshita Kar. Today, I'm going to explain my project on SPI memory design and verification using Verilog. In this project, we use a SPI protocol to communicate with the memory. First, I'll explain the basic concept of SPI, and then I'll explain the memory operation and FSM used in my project. Here we can see the basic idea of SPI. SPI stands for a serial peripheral interface. It is the communication protocol between the master and slave. The master controls the communication and slave responds to the master. The important point is that data is transferred one bit at a time and the clock controls this transfer. So the basic communication is between the master uh, and slave through the SPI interface. Here we can see the four main SPI signal. First one is a serial clock. It is a clock signal and it controls the timing of data transfer. Second one is a master output slave input and it carries the data from master to slave. Third one is a master input slave output. It carries the data from slave to master. And the last one is a chip select line. It select the required slave and start the communication. So these four signals work together to complete the SPI communication. Here we can see the SPI memory architecture. On the left side, we have a master. Master communicate through the SPI interface. On the other side, we have a memory which act as a slave. Our memory contain a 32 location and each location store a 8-bit of data. The design also uses a counter and it is used to keep track of a bit during the transfer. So the basic flow in this diagram is master interface, SPI interface and memory. And now this diagram shows how an SPI transaction takes place. First, the SPI signal select the slave. Next, the memory send the required bits using the clock. Receives and process these bits. After processing, the required memory operation is performed. Finally, the operation is completed and the transaction end. So from this diagram, we can understand the complete flow as select, transfer, process, and finish. Here we can see the two main operation, write and read. In a write operation, the master send the required information and the memory store the data in the selected location. In the read operation, the master provide the required address and the memory retrieves the stored data and send it out serially. The main difference between the write and read operation is the write means storing the data in memory and the read means retrieving stored data. Now this is the most important diagram in our project. Our SPI model uses FSM and it contains 6 states. Here there are the 6 states. First one is idle state, which is used, it wait for a communication. The second one is the detect state and it identifies the model is operating in which state, like read or write. Next is a store, which is used for the write operation, and then we have a send address, send address, which handles the address during the read operation. After send data, it sends the stored data serially. Finally, we have the temporary delay, and it provides the temporary control before the next step. So, and here we are having a FSM flow diagram. Initially, the controller in the Initially, the controller in the idle state When a chip select line becomes 0, it moves to the detect state. Here it checks the MISO, means master input slave output. If it is 1, it move to the write operation, means store state. In the store state, it stores the received data in the memory and FSM move to the idle state. If MISO is like master input slave output is 0, it move to the send address state, wait for the temporary delay and the date uh, and send data through MOSI. After completing the operation, the controller move to the idle state. Finally, this project demonstrate how SPI communication can be used with a memory using Verilog. The memory is 32 location with a 8 bit in each location. We support both the write and read operation. The SPI communication is controlled using a 4 main signals, and the memory operation is controlled using a 6 FSM states. So this project helped us to understand the basic concept of SPI, memory operation, and a Verilog RTL design. This is my design code. Here I have declared the input and output of my model. Inside the model, I have declared the 32 memory location, and each location can store a 8 bit of data. Here I have declared the integer variable called count, and it is initially from 0. The data in is a 16-bit register, and it is used to store the temporarily incoming data, and the data out is 8-bit register, and it is used to store the transfer data through MOSI. Type def enum bit means it is used to create a different states of FSM, and in the FSM, we have 6 states. Here there are 6 states, as I explained in that. Uh, at every positive in the reset state, in the reset state, at every positive clock edge, the model checks the reset condition. If the reset is active, uh, if the reset is if the reset is active, all register active, then all the registers are cleared, become a 0, and FSM move to the idle state. If reset is not active, means it is low, the a circuit enter the normal operation, and a case statement, it checks the FSM current state and executes the corresponding operation. In the idle state, the model wait for a chip select line. When chip select line low, it means the SPI master has selected the memory, so the FSM move to the detect signal. In the detect state, the model checks the first received bit, means MISO. If the bit is 1, it select the write operation, means a store state. If the bit is 0, it select the read operation, means send address state. In the store state, it receives the 16-bit serially. The first In the store state, the model receives a 16-bit serially. The lower 5 bits are used as the memory address, and the upper 5 bits are used as a data. After receiving all bits, the data is written in the selected memory location, then the operation is completed and the FSM returned to the idle state. In the send address state, in this state, the model receives an 8-bit address from the master. After receiving the address, it accesses the memory location and load the stored data in the data out register. In the temporary delay state, it prepares the read data for transmission, and the ready signal become high. The first bit, means MISO, is placed on the first bit is placed on the MISO, and then the FSM move to the send address state. In this state, the stored 8-bit data is transmitted serially through the MOSI. 8 bits are transmitted, the operation done signal become high and IFSM return to the idle state. The last is a default state and it is provide the safety and if any invalid state occur, the FSM return to the idle state. Thank you, sir.